Yeah, good morning students. In this video, I will be discussing on what is error detection and correction, what is Hamming distance, and one of the simple error detection technique known as simple parity check. Okay, let's start. So coming to definition, what is error detection and error correction? So whenever a system is transmitting a data to another system, then during transmission there may be chances of corrupting the data. So there should be some technique to identify which bits are gets corrupted and how to recover it. Okay, that's what here any time data are transmitted from one node to the next, they can become corrupted in passes. So there may be any number of factors that can alter the message, maybe due to system fault or due to link failure or due to involvement of hacker. Anything may happen where the transmitted data may be changing at the receiver side. So first let us see what is error detection definition. So in error detection what happens? We are just checking the errors, whether it is happened or not. So how many bits are changed and which position they are. So like that we are just checking whether the error has been occurred or not. However, we are not going to correct any errors. So the answer is simply yes or no. Means whether the error has been occurred or not. So coming to error correction, so we need to uh, identify those errors and also we need to take some action in order to recover those bits. That is known as error correction. So there are two types of errors. One is known as a single bit error, the other one is a burst error. So in single bit error what happens? See here the sender is sending some 8 bits of data to the receiver. You can see clearly here from left side the fourth bit at the sender side is 0, which is changed to 1 at the receiver side. This means if one bit is changed, such type of errors we call it a single bit error. Okay, it may change from 0 to 1 or from 1 to 0, but there should be a change in only one single bit. So coming to burst error, if there is a change in more than one bit, we call it as burst error. So if you see clearly here, the sender has sent some data here and the receiver has received some other data. The fourth bit has changed from 0 to 1 and the fifth bit is changed from 0 to 1 and eighth bit is changed from 0 to 1 and 11th bit is changed from 0 to 1. So these are the four corrected bits. But strictly speaking, the length of the errors is not only 4 bits, it is complete bits from where the starting bit has changed to the ending bit. That means totally the 8 bits will be gets corrupted. Means the retransmission will be done for 8 bits, not only for 4 bits. So such type of errors we call it as burst errors. Okay. So then how to identify those errors or how to detect those errors. So in order to detect any error at the receiver side, so the protocol should add some extra bits that we call it as redundancy bits. So here I have written to be able to detect or correct errors, we need some extra bits along with our original information. So those extra bits we call it as redundancy bits. So however, after detecting the errors or if there is no errors at the receiver side, those extra bits whatever we have added at the sender side will be removed. So we are not considering that as the original data. We are just adding those extra bits at the sender side in order to identify the errors at the receiver side. Okay. So here you can see clearly this is my original information, the data what I am sending. So what the generator function is doing, this is one of the function at the sender side which will add some extra bits like 1011101. It may be any number of bits. So based upon what type of technique we are using, those extra bits we are going to add. But one point we should keep in mind, As we go on increase the number of redundancy bits, there may be more chances of accuracy in the error detection. So these are the redundancy bit it is added. So at the center side what happens along with the original information. So this is what your original information. I am adding the extra bits, what you call redundancy bits. So together the receiver will receive. Then there is one more function on the receiver side known as checker function that will apply one of the error detection technique, and it will identify whether the error has been occurred or not. So if there is no error, then it will accept the only data. Please keep in mind, not the redundancy bits. If there is any error it is found, then it is going to reject the entire data. So now let us see how exactly it will work. So before going for a simple parity check algorithm, first let us see what is block coding. So normally what happens in networks, whenever we are transmitting any data, we already know that the data will be divided into smaller fragments or smaller blocks. So each block should be encoded. Means each block should be added with some extra bits along with the original data. Those extra bits are also should be sent to the receiver side. So that therefore we are calling it as block coding. Okay, means we are dividing the entire message into blocks, and each block is added some extra bits. Okay, so here each block is known as k bits, means your original information, that we call as a data word. Please keep in mind, here data word means the original information what we are sending is called as data word, which is represented as k. Okay. So as I already told you, at the sender side the function will add some extra bits, so that we are naming it as r. It may be any number of bits. Okay, so for this data we are adding some extra bits k plus r. Okay, then to get the code word, so whatever the resultant we are getting, we call it as code word because it is encrypted. Not encrypted, it is converted into some other form because we are adding the original information along with the redundancy bits. So together we call it as a code word. So that is represented as n. So here n is nothing but k plus r. This is what your code word. So hope so you understood these terminologies. Here k is nothing but the original data bits, so we are calling it as data word, and r is nothing but extra bits that we have added known as redundancy bits. Together what we got, we call it as a code word n. So here I have written on this one. This part we call it as k, this part we call it as r. Together what we got here is nothing but n, which is nothing but k plus r. Okay, so this is the error detection process. What is happening at the sender side, what is happening at the receiver side. At the sender side what happens, as I already told you, the entire data will be divided into blocks. Each block we call it as a data word. Okay, so that we call it as k bits. So what the generator is doing, it is going to add some extra bits r. Together we will get what is known as n, known as k plus r. That is nothing but a code word. So that code word is transferred to the receiver. So the receiver will receive the code word n bits. It may be the same code word or it may be altered. So that is what the functionality of the checker to identify whether the code word received is correct or not. So it will apply any one of the technique. We have different types of error detection techniques, maybe a simple parity check or multi-parity check or CRC, Hamming codes, or checksum, like that we have different techniques. So the checker will do one of the method and it will identify whether the error has been occurred. If the error has been occurred, it will discard the code word. If there is no error, then it will extract only the data word, that is nothing but k bits. Okay, and that is sent to the receiver. So this is the overall process of error detection process. Okay, so these are the various popular error detection techniques we are learning in this CL. First one is simple parity check. The second one is two-dimensional parity check. The third one is internet checksum, and the last one is cyclic redundancy check. We call it a CRC. However, I already made the videos on CRC, checksum, and two-dimensional parity check. So in this video, I will be mainly telling about simple parity check. It's very simple. Okay. So this is what just now I told you, the structure of the encoder and the decoder of the error detection process. So at the sender side, this is what the original message what you are sending, that is nothing but K, and the generator will add some extra bits. Together we call it as message and redundancy, that is K plus R. Together we call it as a code word N, that is sent to the receiver. Then the receiver will apply the one of the technique what I told. It may be a simple parity check, or it may be a internet checksum, or it may be a CRC, whatever it may be. So it will apply that method and it will identify whether there is any error or not. Okay. So in order to understand any of the error detection techniques, we need to know what is an XOR operation. So that's why I'm just telling you what is the XOR operation. So please keep in mind, in XOR operation, if the two bits are 0, then the resultant will be 0. If one of the bit is 1, like 0 or 1 or 1 or 0, the resultant is 1. Okay. If two bits are 1, the resultant bit is 0. That's what I meant to say. If two bits are same, it may be either 0 or 1, the resultant is 0. If one of the bit is different, then we can say the result is 1. So here is a simple example. The sender is sending some data like 10110, the receiver is received 11100. So if you do the XOR operation, so this is what, both are 0, it is 0, 101, 00, 110, 011 and 110. Means if both the bits are same, the result will be 0. If one of the bit is different, the result is 1. Okay, because this XOR operation is more helpful while doing the calculations using CRC, Hamming codes, or internet checksum, all those. Okay. So before going to the simple parity check, let us understand what is the Hamming distance. So Hamming distance is nothing but it is the distance between the two words which gives the difference between those two words, and those difference is indirectly the number of error bits that are occurred. Okay, sender is sending the first bit, means first word, then the receiver may be received the different word or same word. Then if you do the what I meant to say, the XOR operation between those two, then whatever the difference we are getting, we call it as a Hamming distance. So here you can see, let us find the Hamming distance between two pairs of words. So the Hamming distance between this 000 and 011 means sender is sending some 000, receiver has received 011. So just do the XOR operation 011. So by saying this, you can say 01 is 1, 01 is 1, 00 is 0. So how many ones we have in the resultant part, those many error bits are occurred. So here 2 ones are there, so 2 bits are changed. Yes or no? Because first bit is changed from 0 to 1, the second bit is also changed from 0 to 1. So 2 bits are error. So this Hamming distance will help in telling how many error bits are occurred. So similarly, the Hamming distance between these two. So if you can just calculate 10101 and 11110. So 10 is 1, 01 is 1, 11 is 0, 01 is 1, 11 is 0. So 3 bits are changed. So the number of error bits are 3. So in this way, the Hamming distance can be calculated. So there is one more known as minimum Hamming distance. So whenever you are finding the Hamming distance for multiple pairs at the same time, then among those which is minimum, we call it as a minimum Hamming distance. So the minimum Hamming distance is the smallest Hamming distance between all possible pairs in a set of words. For example, this is one of the table. So they are telling find the minimum Hamming distance of the coding scheme. So this code words is telling. So you need to find the minimum Hamming distance of this code word. So what you should do now? You should check the minimum Hamming distance for all. Hamming distance for all the possibilities. What I mean to say, Hamming distance between 000 and 011, Hamming distance between 000 and 101, Hamming distance between 000 and 110. Similarly, 011 and 101, 011 and 110. Similarly, 101 and 110. So all possibilities you need to check. Here I have done that. So among this, which is minimum, so all are getting the minimum distance as 2. So the minimum Hamming distance is nothing but 2. We are representing D minimum as the minimum Hamming distance. Okay. So now let us see the simple parity check, how it will work. So a simple parity check code is a single bit error detection code. It is identifies only a single bit. Please keep in mind, in which n is equals to k plus 1. What does it mean? N is equals to k plus 1 means here k is nothing but a data word. It may be of any number of bits, but in case of simple parity check, the extra bit what we are adding or should be always 1 bit, not more than 1. That's why we are calling it as a single bit error. Okay, and whatever the resultant you are getting, we call it as a n. That is nothing but a code word. Now let us see that. So these are the data words. So this is the simple parity check code for finding the errors or error detection. So this is the data word 0000, which is nothing but k, and this is the code word that we have generated, which is nothing but n plus n is equals to k plus r. So this k is nothing but 0000 and r is nothing but one extra bit we added 0. So overall we got what is known as n code word. Similarly 0001, the code word is 00011 and 0010, 00101. Like that all possible pairs means we have 4 bits, 2 power 4, 16 possible code words are generated. So but the question is here how the last bit is added, that is redundancy bit. It is very simple. So how we got that extra bit means what the function is doing. If you see 0001, so if there are odd number of ones, then the function will make it as even number of ones. If the data bit is already having the even number of ones, then you should put just as the 0 as the extra bit to make it as even. For example, see here what I want to say 0000. So there are no ones, so simply the extra bit will be 0. If you see 0001, so there are odd number of ones, so you should make it as even. So I am just making one more one here, so that becomes even now. 1 plus 1, 2. Similarly 0010, there is odd number of ones, so I am making one more 1 as the extra bit, it becomes even. So if you see this one 0011, so there is already a even number of ones, so I am just putting 0 as the extra bit. So what the function is doing, it is just making the number of ones as even. If it is odd, it is making it as 1. If it is even already number of ones, then it is making extra bit as 0. So hope you understood. So in this way, the code word is generated. Now let us see the working of simple parity check code. So I will take one example. For example, I will take this one only 1111. Then how it is going to detect the errors. Okay. For example, this is 1111. Okay. Same example I am doing. Then all the data word, which is nothing but k, is sent to the generator. So as we already know that the generator will add one extra bit to make it as even number of ones, but it is already even number of ones, so it is making 0. So this generator what it will do, it will take 1 1 1 1 and it will add one more extra parity bit, nothing but a 0, that is nothing but 0 here. So this is 1 1 1 1. So now the whole thing we call it as a code word, that is nothing but n, that is sent to the receiver. Then the receiver what it will do, he will receive the same thing, either the same code word may receive or it may not. So I will show you both the cases. Think that the same code word is received, that is 11110. So what the checker will do, it will extract all the code word whatever it is received, then it will just add all the ones and it will apply mod 2 operation. So for example 1 plus 1 plus 1 plus 1 plus 0, it will add all the bits, it is nothing but 4 mod 2. If you do 4 mod 2, it becomes 0. So whenever the syndrome bit, this we call it as a syndrome bit, the reminder what we got. If it is 0, then the decision logic will think that it is correct. Then it will extract only the data word, that is 1 1 1 1 and it will give to the application. Okay, think that the data word is changed. Instead of 11110, we have received 11010. Okay, now the checker will do the same function. It will add all the bits 1 plus 1 plus 0 plus 1 plus 0, which is nothing but 3. 3 mod 2 you will get, which is nothing but 1. So if the syndrome bit gets other than 0, any other value, then it will think that there is an error. So then what the decision logic will do, it will just discard the code word thinking that there is an error. So one more possibility I want to tell you, think that now 2 bits are changed. So in the first case, everything is received perfect. In the second case, only 1 bit is changed. Now I will try to change 2 bits. So instead of 11110, it is received 11000. means second bit and third bit both are changed. Now you see what happens. Checker will add all the bits, that is 1 plus 1 plus 0 plus 0 plus 0, which is nothing but 2. Then it will do 2 mod 2. Then you will get 0. Then if the syndrome bit is 0, what happens? The function will think that it is correct code word. Then it will extract the data word from that, which is nothing but 1100. But actually the data word is what? 1111. What it is received? 1110. But mistakenly the algorithm function will accept the data, because this simple parity check can detect only odd number of errors. If there is a change of even number of errors, then it won't detect. Okay, please keep this point in mind. So if there are 3 bits changed, for example, 11110 is there, you should think that this second bit, third bit and fourth bit are changed. That is 10000. Then if you add, you will get 1 mod 2. Then you will get 1 as the remainder. The central bit is 1. So then it can detect the error. So what I mean to say, the simple parity check can detect only the odd number of errors. It can't detect the even number of errors. Okay. So that is what the same scenario is explained here. The data word set is 1001 and the code word received is 10111. So if the same data word is received, then there is no error. If one bit is changed, then it can detect the error. If 2 bits are changed, then it won't detect the errors. If 3 bits are changed, then it can detect the error. So the final conclusion is a simple parity check code can detect only odd number of errors. Okay. This is how a simple parity check code will work. So hopes you enjoyed the video. Already I have done the videos on the other 2 techniques like cyclic redundancy check and also uh, internet checksum. So you please watch those videos also. So hopes you enjoyed the video. Thanks for watching and subscribe my YouTube channel for more videos. Bye.